Hi, in this video, we are going to learn on how to calculate the pH that involving a strong acid and strong base, and also for the weak acid and the weak base. First, let's take a look for the calculation that involving a strong acid and strong base. So we have to take note that for the strong acid and strong base, they are completely dissociate in aqueous solutions. That means the reactant of acid and base that involved in the reaction are completely ionized in the reaction. Therefore, the concentration of the hydrogen ions and the hydroxide ions formed can be obtained directly from their molarities, which means the concentration of H plus and OH minus ion that produce after the dissociations is equals to the concentration to its acid and base that has been introduced during the reaction. Now, let's discuss on how to determine the pH value for the strong acid. This is an example to calculate the pH of a strong acid. The question is, calculate the pH of 0.15 molar of the hydrochloric acid solutions. To determine the pH, we can use ICE table. What is the ICE table? ICE means I for initial, C for change, and E for the equilibrium. So that is what ICE stands for. We have to draw the table as well as write the balanced chemical equation. Now, we have to determine the concentration of each of the substance that involved during the dissociations. In these questions, they are already given the initial concentration of the hydrochloric solution. Therefore, we can insert a value into the ICE table. The initial concentration of HCl given is 0.15 molar. Since this is the initial conditions, that means the hydrochloric acid does not dissociate yet. Therefore, the H plus ions and the Cl minus ion with zero concentrations. But during the reactions, there must be a change in the concentration of the reactant as well as the product. But the question is how much that the HCl has been dissociated during the reactions. Remember that the HCl is a strong acid. The strong acid dissociates completely or 100%, which means after the reaction, there are no more strong acid left, but they are completely dissociated to form its ions. Therefore, we can assume that the amount that dissociates must be equals to the amount of the initial concentration that has been introduced before the reactions. So the change of the HCl concentration is minus 0.15 molar, which means 100% of its concentration is completely dissociated during the reactions. But when the dissociation occurs, they must form the ions in the solutions. The concentration of the ions formed must be equal to its initial concentration of the strong acid that has been introduced in the reaction. That is, H plus has produced 0.15 molar, which is the same amount of initial concentration introduced, as well as the Cl minus also produce 0.15. The sign of positive used means refer to the product form, which means the concentration increase during the reaction. The minus sign means the concentration decrease for the reactant. So, at the end of the reactions, until they reach the equilibriums, we can determine the final concentration for all the substances involved during the dissociation. For the strong acid of HCl, since the initial concentration is 0.15 molar, during the reaction, they have been completely dissociated with 0.15 molar. Therefore, finally, there are zero concentration of hydrochloric acid. But for the product of H plus ion and Cl minus, since during the reaction, they produce 0.15 molar to each of the ions, therefore finally, we still have remaining 0.15 molar of the H plus and 0.15 molar for the Cl minus. So, from the ice table, we have determined the equilibrium concentration of the remaining substance is H plus concentration equals to 0.15 molar, as well as the concentration of Cl minus with 0.15 molar. Now, to determine the value of the pH, it only depends to the concentrations of the H plus. So, we can use the concentration of the H plus to determine the pH by using the formula of pH equals to negative log of H plus concentrations, and substitute the value of the concentration in the equations with 0.15 molar. Therefore, it will obtain the pH that is equals to 0.82. So that is the pH for the strong acid of HCl 0.15 molar. Now, let's take a look for another example for the strong base. The question is, calculate the pH of 0.20 molar of NaOH solutions. So take note that the NaOH solution is a strong base. Using the same method, which is using the ice table, so we have to write the balanced chemical equation into the table, which means the dissociation of NaOH solutions. So the NaOH solution will dissociate to form Na plus ion and OH minus ions. To determine the pH, we have to determine the concentration of each of the substance after the dissociations. First, insert the initial value of the NaOH solution. So the given concentration initially is 0.20 molar. So since this is the initial conditions, which means NaOH is not dissociated yet. Therefore, there are no Na plus and OH minus ion produced. But then, after the reaction occur, which means the dissociation, so there must have changes to the concentration of both reactant and the product, whereas the reactant will decrease in concentration, the product will increase in concentration. The reactant here is NaOH, aqueous solution. So it will decrease during the reaction. So we use this negative sign to show that the concentration decrease. But how much of concentration decrease for this NaOH? So take note that NaOH is a strong base. So for a strong base, the dissociation is 100%, which means the initial concentrations that has been introduced in the reaction must be equals to the amount of concentration that has been dissociated. Therefore, for NaOH aqueous solution, the 0.20 molar that has been introduced initially is completely dissociates with the same amount of concentration, which is decrease 0.20 molar. But since during the reaction the product form, therefore Na plus and OH minus will form during the reaction. They will form as much as the concentration of NaOH dissociated. That is, increase in concentration of 0.20 molar as well as for the OH minus 0.2 molar. Finally, at equilibrium, the NaOH remain zero concentration, which means 0.2 minus 0.2. Therefore, no more NaOH left after the reaction. That shows how the NaOH is completely dissociated during the reactions. But for Na plus, they have increased in concentration with 0.20 molar. So at the end of the reaction, they still have 0.20 molar. As well as the OH minus, the ions also with the same concentration, 0.20 molar. So now let's observe the ice table with all the values that has been calculated. So we can see at the end of the reaction or at equilibrium, we still have remaining Na plus ions and OH minus ions with 0.20 molar. But NaOH is completely dissociated. So we can make a conclusion that is the Na plus ions produced at the end of the reaction is 0.20 molar, and the concentration of OH minus ions is also 0.20 molar produced. So to determine the pH, we need the concentration of H plus ion. But then, from the calculation using the ice tables, we only have the value of the OH minus. So, how to determine the pH? We can determine the pH by calculating the pOH first. That is, using the concentration of OH minus in the formula of negative log of concentration OH minus. So substitute the values, negative log 0.20 molar. That obtain 0.69 pOH. So, what is the pH of this solution? We can relate the pH with pOH, where is pH plus pOH is equals to 14. Since the pOH value is 0.69, therefore, we can rearrange the formula to determine the pH. Thus, it will obtain the value of pH 13.30.